Right, so welcome to C101. We're getting the slides up. I don't know if we're going to get the slides up, but as you know, you're here to listen about the evolution of encoding options. So my name's Don Robinson. I'm one of the contributing editors for Streaming Media Magazine, usually based, as you can tell, by my wonderful plummy accent over in the UK, but over here on regular occasions, mainly for the Streaming Media events. I also wear a different hat, and I run a software company, and we build encoding clouds for people, mainly for enterprises who've got very specific high availability requirements. But do come and talk to me about that later, because you're much more interested in our wonderful panel. So I'm just going to read out from the session description, so you know you're in the right session and we're all on the same page. So there's a growing number of vendor options when it comes to encoding video, but each one is different in terms of feature sets, distribution functions, audience reach, monetization opportunities, interactivity, and many other factors. This session will compare the panelists' offerings, discuss the technical features that they're bringing to the market, and where they see demand for new capabilities from their customers. The panel will help you understand which platforms and approaches are best suited for specific video content and consumer use cases, as well as overall business goals. And it will discuss how the market for encoding services is evolving and what we should expect to see in the next 6 to 12 months. So I'm going to ask each of my panelists to just briefly introduce themselves, talk a little bit about where they've come from and what their particular interest is within the context of this session. And then I'm going to start firing some tricky questions and see if we can get some interesting answers out of them. So, James, can I start with you?
Hi, I'm James Jackson with Wowza Media Systems. I am the Director of Technical Product Marketing, which, as my boss says, I'm the Director of Who Should Care and Why. And a lot of the things we're working on have to do with a lot of use cases in terms of where we see things developing, specifically around layers of interactivity and what we used to call gamification, but a lot of democratization in terms of what's actually required there and some of our products and features for doing those sort of things. And so that's really what we're focused on right now, and that's where we're driving a lot of things, and those are the whats and the whys of why we're doing a lot of things in our development strategy as we continue to move forward.
Perfect. Thanks, James. Dan.
Hi, I'm Dan Germain. I work for AWS Elemental, which is obviously part of Amazon. I saw Keith did a great job of explaining that we're very much customer focused. And part of my job at Elemental is I'm responsible for all the file-to-file transcoding, so compression at Elemental. We're split up in two groups. There's like a live half and a file-to-file half, and I'm responsible for that. We're very much being customer obsessed. We're very, very much on the sharp end of really trying to deliver the latest and greatest future standards, which I know Dom's going to ask us some questions about as we move forward. And I would very much appreciate come up and say hello and ask me more questions afterwards.
Perfect. Mahmoud. I'll wave the hat.
I'm Mahmoud Al-Daccak. I'm AVP Product Development and CTO at Haivision. My responsibilities around everything that has to do with the products, whether it's product development or product management or whatnot. And we cater to specifically live video and I would say situational awareness as opposed to many eyeballs.
Hi, my name is Dror Gill. I'm CTO and VP Product at Beamr. Beamr is a leading provider of video encoding and optimization solutions. And we serve mainly the MSO, telco, and the OTT markets. Our primary focus is on software solutions for encoding H.264 and HEVC. We have very high density and very high quality HEVC encoding solutions. And our focus is always to increase the quality and to reduce the bandwidth as much as possible using our optimization technologies. So that's basically where we are focused today in the industry.
So I find it interesting from a personal point of view. I've been in the streaming sector for about 20, 21 years now, and historically encoding panels always used to be a bit of a box shootout. And when I was talking to Dan about putting this panel together, it was quite interesting that actually across this panel here, we've got a whole group of people who are actually kind of orthogonal to each other. They're all in the same space, but they all actually do something quite distinctly different from each other. So I think it's quite interesting. Just to start off with a little bit of a chat about the sort of product focuses and why you're putting those products specifically into those into the places you're targeting. And I know, let's start with James, because I know you've launched your new transcoding engine over the last few months. What's taking you into that space particularly at the moment?
Yeah, that's great. So the new product I believe you're talking about is the Clearcaster product. And so you'll probably get me beat up if we call it an encoder specifically, but it's an appliance, and so it does a few different things. And so when I talked a little bit about democratization, so the ability to do things and provide a very high quality broadcast onto a system. And so specifically with that product, we worked very closely and partnered with Facebook to deliver that particular product, and people wanting to actually deliver their content and syndicate that to Facebook Live, and talking about a lot of the issues that people are actually having with being able to deal with that. And so if you think about a traditional encoder, a lot of the things you're doing, there's a lot of intelligence on this side of the keyboard. So, what GOP size do I need? What format, what actual resolution do I need to actually push at that point in time? And then beyond that, also, a lot of the problems people have with actually keeping that stream up and recovering from something when it goes down. And so we actually approached it from the standpoint of, what's the actual user theory of operation, or, their kind of quick start guide in reverse, what's the experience you want people to actually have, and built from that standpoint. So you're not actually touching a lot of the things that you would ordinarily see, like, I mentioned, the GOP size on the format and the actual resolution. Those things you're not actually touching. We're actually dealing with a lot of those things, but instead focused on the experience in terms of if you want to go to that particular medium and work with that type of interactive experience, so a user-directed, user-driven, but also at a very high quality, something that recovers very well. And it's specifically built around that particular use case. And so a lot of the things you would see in a traditional encoder, you're really not going to see in that actual product. Not that they're not there, it's just that a lot of that, we've actually pushed that intelligence to the other side of the screen. So we're taking that piece away from you, but it's really along the lines of focus. When one of the things I always talk about is when a lot of people in this room and in this business, we got into this because we like to solve hard problems. Fundamentally, I always think that if you make the hard problem that configuration, then people are going to spend a lot of time doing that sort of thing, and they're not going to focus on the problem you want them to solve, which is actually producing that really cool experience. And so that's really what that one's built around in terms of that interactive experience.
So it's very interesting as a software company producing an appliance in the market, which actually moving on to Dan, you're an appliance, traditionally Elemental perceived as an appliance vendor, very much embracing the cloud now. So talk about the Elemental changes over the last couple of years and where you're finding your position.
Yeah, it's very, very interesting. So obviously Elemental was primarily a software defined company and still very much is, even though it's part of AWS now. And for us, it's been very interesting because we've been taking on some quite big technical challenges. So obviously we just heard Keith talking about Thursday Night Football, but fairly recently at NAB, we did the live 4K stream from the International Space Station. So that's like a world's first. And those sort of big, really strides in technology is where we're really trying to push software to its limits. But it is interesting you talk about hardware and appliances, because there's still a great number of large enterprise-style customers out there which still require appliances. So one of the strengths I think that Elemental brought to the table with AWS is the fact that our software, whether it's running natively in the cloud or in a VM or on an appliance, is exactly the same software. And really sort of my goal and the challenge I've had the past, I suppose, couple of years is really enabling these large enterprise customers to be able to basically migrate or generate hybrid solutions. So, I'm sure we've heard of the term cloud bursting, as they all eventually will transition to an OpEx model, because that just makes sense for business. If you've already invested millions of dollars in a lump of hardware on the ground, that's paid for, it's going to be cheaper than, taking those AWS charges each month. So I'm just really managing the transition of these big customers from traditional ground appliance and, SAN type solutions into a cloud environment.
Mahmoud, you guys look more at specific focuses and specific industry sectors and so on, perhaps a little bit like my own company does. Talk a little bit about what you guys are doing and where you're finding the demand at the moment.
Sure. I mean, our main catering, I opened up by saying, situational awareness video. So what I really mean by that also is that it's either mission critical decisions or mission critical messaging, and that's what we really focus on within like 3 industries. I would say like the broadcast, defense, and the enterprise. And within these contexts, what's important is to make sure that you get the video somehow. So our company is engaged in the encoding side for portable encoding, these are on platforms, whether they are on a drone, for example, or they are in a camera somewhere in a stadium, relaying back the video for somebody to make a decision on something, basically. So that's why our entire focus is the low latency and the efficiency of encoding because of the constraint pipe that we encounter. We don't really cater to VOD from that point of view, so it's all live. And what's important is to get the message so that you can make the right decision. So whether you are driving a drone halfway across the world, you want to make sure that you make the right decision for that mission critical situation. Or whether you're doing remote officiating, for example, with bringing back the video from different stadiums to make a remote officiating centrally, let's say in New York, as for the NFL in our case. Again, the idea is how can you get the best picture out of your encoder? How can you move it across the network the best way, the most reliable way? And then how do you decode it and display it in the lowest latency possible? That's the core focus in our encoding industry.
You sound perfectly prepared for this panel. That's exactly the right broad range of things. And obviously, no conversation about encoding would be complete without talking about codecs. So, Dror, talk to us a little bit about Beamr and what you guys are, what the demand you're seeing in the market is that's led to the production of the Bema Codecs.
So we also believe in software. We're with Amazon on that, and we think that the flexibility that is offered by software is the best solution when you need to match different requirements in terms of codecs and protocols, delivery mechanism, protection, etc. So we've been focused on developing these software codecs that have very high performance and high quality. People used to think that if you want to encode HEVC, which is more compute intensive than H.264, and if you want to do 4K, which is 4 times the resolution of HD, you have to go with hardware solutions. And that was the reality until 1 or 2 years ago. But now we've taken our codec software really to the extreme, and we've been partnering with Intel on their new Intel Scalable platform, and using the resources of the Intel Scalable Platinum, which is the 8180, we've demonstrated recently at IBC the capability to do 6 live channels of 4K P60 at 10-bit HDR on a single Intel server. And we're doing this purely in software. And we believe that with software that can give you this type of density, you can really have both the density and the flexibility that enable you to stream as many channels as you want. Now, if you don't have 6 4K channels, you can also stream 16 HD channels at 60 frames per second, or do a full ABR stack. Now, the ability to do a full ABR stack on a single server is very important, because if you can't do that, you need to split your mezzanine stream into several servers, and that becomes complex. So if you can do your 4K P60 and P30 and your 1080p, 720p, all of that on a single server, it really means that you can take these full live channels and dedicate a server for each one of them, and be able to stream them to your users regardless of what device that they have and what is the device capabilities.
Perfect. So I'm going to draw us into a little bit about the hardware and software changes in the codec market in a moment. But for the moment, can we just talk a little bit about codecs? So codec evolution is always a great battlefield in the streaming media dialogues, in the magazines, in the forums, and I kind of miss the Windows Media and Real Media days, to be honest, because there was much more punch-up in those days. But so at the moment, HLS dominant, right? Yeah, H.264 dominant. Is that the picture? Is that landscape changing? James, have you got any views on that?
So the landscape is changing. We've traditionally taken an approach where we're going to take whatever you give us and we're going to produce and syndicate into lots of formats. With software, we definitely see a lot of legs left in 264 in terms of outbound, in terms of pushing things out. HLS likewise made lots of strides. People have made lots of strides in terms of actually dropping the latency with HLS as well. But at the same point in time, there are lots of other things that come on the market. But I guess the short answer to your question is yes, definitely see a lot of legs left in 264. I think over 2018, people definitely start to adopt more and more 265, especially as people get more of the closer to 4K type of and just want to deliver those types of experiences. But at the same point in time, there are a lot of people, especially that we see, especially when you get into a lot of the things we talk about, user-defined, user-generated content, that, still definitely have spent a lot of time customizing, patching their workflows for 264. And I think a lot of those things are actually going to still continue to live for a little bit of time here, especially over the next 6 to 12 months.
Dan, do you share that view? You seeing any trends in the codec space?
Yeah, I see massive trends, actually. I'm thinking more about fragmented MP4, so CMAF, and this sort of holy grail of being able to have, your dash and, your HLS basically sharing the same fragmented MP4 media, so drastically reducing the size of the storage you need, and then you're just effectively, generating the manifests that you need. And the great thing about having fragmented MP4 with HEVC, because that supplies us obviously the 4K and HDR flavors that you need as well. When we start looking at the premium content customers who, that's in the studios who are really trying to manufacture all of this media, storage is their biggest, incumbent costs that they're trying to remove. So when we can start thinking about, okay, we can have a 4 and 8K Dolby Vision master, and then you can transcode this to different HDR flavors now, and deliver that to a stream and actually have those assets as a single format. That's actually a big change that I think we should all be aware of.
Okay, Mahmoud, with your sort of niche focus I'm going to use a little bit of my own experience as a reference to the next question. So we do a lot of corporate streaming for corporate disclosure, fair disclosure stuff, and we're still seeing about 6-7% Windows media streaming for enterprise networks. So it's interesting how long the tail can actually be with codecs and so on. Yeah. So in your niche cases, have you seen, before we start looking too far ahead forward, are you seeing long tail existence of codecs that are still have niche capabilities, niche functionality, which actually still makes them superior to anything that's being developed today?
Right. So, again, I think, H.264 is dominant, and we're seeing a lot of movement towards HEVC, but as you said, within our industry, at the end of the day, it's not the standard, it's what's trying to do. Especially in our domain, where we're catering to the contribution of video and distribution of video, not necessarily delivery to the end consumer. So our solution tend to be more of a closed loop solution. And what's important is to get the job done. So just to give you a pure example, in an enterprise, for example, where you have an all hands and in a headquarter, and you have your branch offices, well, the most efficient way for me is to send the video from the headquarters to these branch offices over gateways, for example, maybe in HEVC to save on the bandwidth. And then within the branch office, my gateway will distribute that over H.264 to the different set-top boxes or mobile devices or whatnot. Does it really matter what codec? No. What we're using HEVC for is the efficiency. Same thing with our, let's say, within the ISR, the intelligence, surveillance, reconnaissance on the drones. We always used to send basically high bit rate, higher quality streams down to the ground station in any theater of operation, and then sometimes they need to send also 2 streams up to the satellite to be backhauled for the drone driving. Those used to be like lower resolution H.264, for example. Well, with the advent of HEVC, I'm able to keep the quality of what they have as an HD without having to go to a lower resolution H.264 and send it up the satellite HEVC. So at the end of the day, I'm a user of a codec. I'm not a developer of a codec, and I'm using the best codec that give me an advantage in support of my use case.
And Dror, you do the crazy stuff. You do the maths. You actually do the codecs. Now, I look at my own developers, and we do orchestration, we do all the control systems and layer over the top, but they always say, no, leave the codecs to the guys who do the maths. So tell us about that journey. Deciding to enter the codec market in its own right is a kind of a tall decision to make, I'd have thought. And you guys are, you're making some inroads.
Yeah, we've been focusing on the quality of images and videos from the start. We started as a company that does optimization for images, actually, reducing the size of JPEGs 50 to 70%. And then we moved to video and optimizing video streams and reducing their bitrate based on a very sophisticated perceptual quality measure that we developed for video. So we've always been in this space of looking at video and finding all of those redundant bits and removing them in the most efficient way possible. And when we did our H.264 product, it was a standalone product that is integrated in your workflow after your initial encode. So you encode your video, and then you reduce the bit rate. But then we found that in order to reduce the latency and improve the quality and improve the efficiency, it would be better to do the bitrate reduction inside the codec itself. So at that point, we decided to acquire a codec company, and we did a survey, and we checked like 10 codec companies, and eventually we selected what we thought was the best codec company in the world, which is Vanguard Video. And last year we acquired them, and since then we've integrated the optimization technology into the codec, and we made a big bet. We bet that HEVC will be the leading codec going forward. So we've integrated the optimization technology into the HEVC encoder, and that has worked pretty well, reducing bitrate between 20 and 50%. Now we are in the business, I mean, our customers are in the business of delivering to the end user. So these are not closed systems. If you make the wrong bet and no user has that type of codec, then you have a big problem selling your encoder. Luckily, this year there has been a major shift towards HEVC with the Apple announcement in June at WWDC that all of their devices are going to support it. Since then, iOS 11 has been released, and we expect by the end of this year hundreds of millions of HEVC-capable devices in the market. And I think this fits perfectly with our strategy of making a big bet on HEVC and going ahead and improving the quality, reducing the bitrate, and as I mentioned before, improving the density of the solution in time for this market that starts to pick up 2018.
So I'm sort of probably going to come back across this way, actually, on this one, because I want to start this question with you. So a big change in my view over the last sort of 5 to 8 years has been the traditionally sort of consumer-grade chipsets have had GPUs added for gaming, for low power, long duration on batteries. And those have actually done something unusual and swum upstream into the servers. Mm-hmm. Normally technology starts in the servers and trickles out, but GPUs have gone into the chipsets from the consumer end inwards. And I think that's changing the encoding landscape. In fact, this is a question to all of you on the panel. I think the appearance of the GPU on the common chipset in the cloud is going to be transformative. And I think that the ability to drop codecs in or use them because they're available on the hardware transforms the cloud model. Do you think that's a fair assertion? Feel free to, any of you pick up on that one.
Well, first, I think that even though we are a pure software solution, where a GPU is available, we will use it, and we will use the hardware macros inside to accelerate our encoding, but we always add our special sauce on top of that to ensure that it's the best quality. For example, there are some GPUs that don't support 10-bit encoding, and a lot of our customers, especially for HEVC, they need the HDR capability. So we can take underlying hardware that's 8-bit encoding, and in software improve and refine the encoding parameters to enable 10-bit encoding. And this enables us to do really high-performance stuff. Like we can take, we partnered with Intel, and we're taking their E3 chip, which is like a $400 chip, and we can do 4K P30 encoding in live on this chip in 10-bit HDR using a combination of hardware and software. So I think always utilizing the best platform you have available will bring you the best density and quality for video encoding.
Got to remember the microphone. And Dan, so looking at AWS, how prolific are the GPUs, GPU and hardware encoding within AWS? Is that expanding? Is that something you're seeing?
Yeah, well,
or is it kept all to elemental?
Yeah, no. I mean, if you look at AWS as a whole, obviously we have large availability zones of CPU. We have there's regions where you can get GPU. One thing you didn't bring up there was FGPA. And I think, since Amazon has obviously, we launched the FGPA series in EC2, sorry. The economies of scale you can get with those are actually way above and beyond, as in the power consumption versus what you can actually render through those FGPAs. So I think as AWS, we really don't mind. As AWS Elemental, we'll utilize all of the technology based on what region you're in and what your utilization is. And what's quite interesting, and maybe people don't know this about AWS Elemental, is actually we write every bit of every byte of our encoders as well. And the advantage that gives us is when we're looking at things like FGPA or GPU or CPU, we have a lot of control over how to utilize those instances, whether they be on an appliance or in the cloud.
So encoding is not just about what's happening in the core of the networks, it's also about what's happening in the field. And we've got the Clear class, we've got some of the Haivision products and so on, they're out in the field. How, are you seeing GPU taking effect in the field, in your field kit? Are you leveraging it with your product, James?
So for a while now, we've supported GPU acceleration in the flagship product of the streaming engine. And so regardless of whether or not that's in our own service offering the Wowza Streaming Cloud, we certainly leverage GPU acceleration, certainly in our new ultra-low latency product, but then also we definitely see people using it. And so some of our load testing as well, you know, when you're doing your transcoding or encoding on the actual server as well, you know, we talk about the limitations. You walk down the scale looking at the actual physical bandwidth there and then the processor. And so in our testing, definitely been able to offload, you know, up to 80% of the processor load with GPU enabled. And so definitely the ability for folks to scale. So one of the big things that people always work about is, you know, what can they scale to? How quickly can they do things? And GPU has definitely been one of those things, very, very big uptake of things. And people definitely like that capability to just increase their efficiency. You know, the cloud model has always been around, you know. It's kind of funny, people call it Uberization, or just the ability to use that extra capacity when, quite frankly, you know, the folks at AWS were really the first to kind of seize on that, to actually take advantage of that excess capacity, and GPU acceleration definitely pushes that even farther for efficiency.
Okay, let's talk about the white elephant in the room. Let's talk about latency. It's been 2017. Every conference, every event I've attended this year, it's been latency, latency, latency. I think if anything was order of the day, live streaming latency is critical. So, what are the challenges that you're seeing your customers facing? Let's start on that end. James, I'm going to start with you and do a normal left to right sweep. So, James, what are the challenges that people are seeing with latency, and what sort of steps have you been taking to address those?
So when it comes to latency, people have been able to achieve pretty darn low latency. I mean, you know, sub 2 seconds for a while. Where the problem really came in is actually trying to scale that up. So, you know, you're talking about a group of, you know, tens or hundreds or even low thousands, but say you want to do that to 10,000, 100,000, what's the actual problem there? Or conversely, at great distance too as well. So getting some sort of similar latency to somebody who's in the room here versus somebody, say, in Australia, you know, what's the actual issue there? And so a large part of what we've been doing is we've taken some things that we've been using internally, so communication between servers or within our own cloud infrastructure, and making that sort of technology available on the edge as well. So actually extending those sort of capabilities. So taking, you know, the Wowza protocol that we've used internally for a while and making that available for an ultra low latency service. And so that's something that we've actually been testing in preview for a little while now and seeing really great results in the ability to achieve, you know, sub 2 second latency at very, very large scale over very great distances. And so it's something we've been playing with for a while, but not only doing that, but also offering it as a service. So lots of these problems you can achieve with, you know, like, let's say an ounce of prevention is worth a pound of cure. Well, it'd be kind of the pound of cure approach, you know. It's a large amount of infrastructure, and we're really actually delivering that to people as a service. So something that really through an API you can sign up with, pay-as-you-go, very scalable, burstable, scale up, scale down as well. But really offering that as a service is something that people can actually use. So,
Dan, do you think the problems in latency as a whole are to do with compression, or do you think they're to do with getting the compressed video from point of origin across the network?
So that's a really interesting question, because, you know, we've just spoken about we can speed up the latency and encoding by using GPUs or FGPAs. Where it gets really interesting, and we talk about the Thursday night football example, though, yeah, you probably saw it was quadruple redundancy across multiple regions. Where the technology gets really interesting is when you're frame synchronizing over 2 different geographic regions. So if you have a high availability environment, which is what Thursday night football is, and then something fails, the users at the end can't see that. And I think that's actually where solving that latency problem, so that you've got these 2, you know, vastly different geographic regions in sync, so if something fails, the end users will never see anything. That, I think, is the real problem. I think we can solve the actual latency point to point. It's the actual doing this on a, you know, millions of viewer scale is the difficult part of the equation.
And I think we also threw away working low latency solutions. As an industry, we've moved away from RTMP, and some of the session-based protocols were perfectly good. I mean, Mahmoud, you were talking about specific use cases. Are you still using specific transport streams, specific different transport technologies for those ultra low latency things? I presume your drones aren't being flown over HLS, because I said they were flying over HLS.
So, I mean, again, I believe that environment dictates technology, not the other way around, and use case dictates technology and not the other way around. So yes, in all our products, we use the usual dash, HLS, and all these delivery mechanisms. At the same time, transport streams remains really like SDI distribution for broadcasters, transport stream for streaming, right? So what we decided to do is we need to move that reliably across, unmanaged networks and whatnot, and we had SRT, which is Secure Reliable Transport, which we use it actually to protect the streams from packet loss and network conditions and whatnot, and also secure it end to end. So that's the use case where you have from the originating point to the destination over SRT as potentially a replacement for a transport stream unreliable over UDP, or an RTMP that suffers possibly from not high efficiency of using the pipe. There's some latency introduced in there, the lack of support of multi-track audio, for example, and all that. So again, I mean, I go back to, it's really the use case that dictates what are you gonna wrap your streams in. The same thing I would like to circle back, if I may, a little bit into the CPU, GPU, and all that. Again, I think environment dictates the technology, and I think we're fortunate enough to be playing with devices. Either they are portable devices that they need to fit in constrained spaces, or servers sitting in data center. And for that, really, we look at the technology as what can it enable me. So we use ASICs, where I have to use ASICs. When I need to have 18 watt, for HD 18 watt, there's no other solution but an ASIC. Whatever the technology is, it doesn't matter, right? However, at the same time, we use FPGAs where we need to use FPGAs. And whether it is in a portable device or actually in data centers, we're fairly advanced in actually using FPGAs, and it's great that those F1 instances, they're giving us great advantages. And I think that where density matters, they might definitely trump CPUs. However, in certain boxes, we do leverage the CPU and the GPU, however it is. In one box, actually, we leverage both an ASIC, CPU-based, and a GPU just to get 4K P60 for H.264 and HEVC. And I fully value the Vanguard codec for sure. When we started, testing 5 different codecs on CPUs. And we wanted to use a codec that was able to serve us from, 300 kilobits for 720, believe it or not, to 50 megabit, for HD or 4K. And for that, we went with X265, and we worked very, very close with them to actually exploit the codec to the extent possible to serve our purpose. Again, I go back to, it's not really about the technology, it's how can I exploit whatever available to me, a codec from a vendor or a hardware from another vendor to service my use cases, which are sometimes unique.
Okay, so I just want to ask you to reevaluate the latest version that we released a month ago and compare that to X265, and I think you will be surprised. You can refer to the blog post we posted last month about this comparison.
So can I raise the specter of AV1? AV1's, it's undercurrent news. People are talking about it a lot. It's obviously not much out there to play with yet. The rumors are it's still got quite a long way to go before it's going to be in a good shape to release. Has this come across your radar, guys? Is this something that's on your product map already, or is it still in the R&D lab at the back of the office? James?
For us, I think that definitely falls in the discussion category. So, when Charlie and Scott Kelliker and those guys sit around talking about architecture, it's something that comes up. That being said, I guess I would say that, as Mahmoud said, we are very much in the standpoint of, what's the actual use case for it? What are people actually trying to achieve with it? Working from that user story outward from there. And so, from a practical standpoint, we're really not trying to implement solutions looking for problems. And so definitely we see a lot of potential there as well, but we have to move things beyond what we think is actually cool to what people are actually needing to deliver. So.
I think everyone agreed with that.
Oh, yeah.
Right, guys, we've got about 6 minutes left. So are there any questions from the floor? Brilliant. I'm going to come down there and play show host. He was first. Here we go.
Hello, I'm Oliver Gunasekara from Codec. So my question is about VP9. I actually did a blog post showing that the installed base of endpoints that can take VP9 today is about 2x that of HEVC. It's about $3.6 billion units, sorry. So we haven't really talked much about VP9, but actually, you know, if you want to stream to browsers or connected TVs or phones, there's a very big installed base, and obviously it's not as big as AVC, but it can potentially half the bit rate. So it's a much better user experience.
Well,
Dror.
Yeah, we actually did a comparison of VP9 to HEVC. You can find that on our website, on our blog. In terms of tools, we are pretty convinced that HEVC is much more advanced than VP9. VP9 does have some advantages when you're talking about low complexity decoding in software on some of the devices. But I think eventually you need to look at the whole ecosystem from encoding to playback. And I think on the encoding side, what you want to do to get the highest density, you need hardware support and hardware acceleration for a codec in order for it to be viable. So you need all of the Intels and the AMDs and those platforms to support your codec. And I think HEVC is very well supported on that front. And you know, we've been able to leverage it through our partnership with Intel. On the device side, I think there has been uncertainty, but now with the Apple announcement and with Samsung announcing that the Galaxy S7, S8, and all of their high-end tablets support HEVC, the Qualcomm chips, I think this landscape is changing. And on the device side as well, in order to get long battery life, better power consumption, you need hardware support in order to stream hours of video to the end user. So I think with the support that we have in hardware, this is what will tip the scale. And we'll see more and more services coming out to the capable devices, which are now the high end, but going into 2019, 2020, it will be across the board in mobile phones. We'll see the HEVC market just growing. I mean, everybody can enjoy lower bit rate, higher quality.
Very quickly, so I think we're almost unique in the only codec vendor that has built both. We have an HEVC offering, we have a VP9 offering coming. It's not quite there. We absolutely want HEVC. You know, we've invested the last 5 years in it. So from a technical point of view, yes, you can see that it's not as sophisticated from a tools point of view, but in reality, we believe it's within 5%. They are very, very close if you use all of the capabilities. So we don't think there's going to be a measurable difference in bit rate between VP9 and HEVC, specifically for our encoder. And as I said, we have built both, so we know. Secondly, I completely agree with you on hardware support, but I think you'll find that any mobile chipset today, Qualcomm, MediaTek, Intel, all of them have VP9 decoding, just as they have HEVC decoding. So from a hardware point of view, I think VP9 is as well supported, but you have the big advantage that you don't have the $4 royalty hit that a low-cost Android provider will not enable with HEVC.
That's great. We had a question down here somewhere as well.
Yeah, so we have to support older devices and older phones and all that. So I was here 2 years ago to stream Media West, and everybody was talking about the container with MPEG dash. And I was like, oh, I have to look into that and stuff. Now I'm hearing HEVC, that's what's like splattered and live streaming. And I know it's a codec that I guess you need to package in the MPEG dash. But how, like, why should I go into HEVC? Whereas I think maybe 2 years from now, it's going to be something else. Like, it seems like there's always something different, and there isn't a standard. And we have to support, whether it's in Africa and other countries, older devices that people have, whether it's Android whatever. So what should I be doing? I mean, because you're talking about HEVC, and it's great for HD, but we have to serve low bandwidth, older devices in countries. So I'm trying to see where HEVC would fit in with our long tail of devices we have to support.
Any thoughts from the floor? Mahmoud?
Yeah, so again, I mean, I definitely hear your pain because everybody's just focusing at the end of the day at the codec. I think what's going to dictate the codec is at the end, I don't believe technology or how many percentage plus or minus are going to dictate it. I'm sorry to say that it's politics going to dictate it. Somebody's going to own the end devices and they're going to dictate a standard. That's how a standard becomes a standard. So we need to keep following that, figuring out how it is. Apple did, make a big statement, and we'll see how it goes. Is it going to be a deja vu of the H.264 versus VB8? Where H.264 completely won with Apple, or is it going to be still a mix? And I guarantee you that next streaming Media West, you'll hear another buzzword. So I think I would say, focus on what's your consumer, who's using you, and which devices they will be using, and that's going to dictate it. I think there are certain things that you have to move forward with. So if everybody is moving to Dash, well, that's great. I've been hearing about Dash for the past 5 years. Again, they started very ambitious, came down. So I think Dash now, I'm seeing a lot of traction on it. And Bitmovin has some nice statistics about that, and HLS. On the codec side, I would love if the conversation starts moving to how can we make the codec a little bit more intelligent, or how can we help it? I honestly can't say that the H.264 versus HEVC versus AV1, they're all using the same fundamental compression technologies. They're just more tools, more complexity, more, which means more compute and all of that. I hope we're going to start having some focus, similar to Beamr, where I'm going to try to help my codec. From what I know about the scene, I want to help it a little bit to be more efficient. In our domain, there is many things that you can deduce from the video to tell it, okay, don't be too clever for your own good. Here's what you should do, right? So I hope there will be some investment along the lines of how can we make the life of the codec a little bit easier, and we stop debating HEVC better than AV1. I think both of them need some help at the end of the day.
Totally agree. So, guys, we've actually run out of time there. I just wanted to say I have a list about that long of more questions to ask. This is a big topic. There's plenty of networking sessions and opportunities to chat with all these guys. I think a little last message from me, just with a little bit more with my writing hat on, which I won't wear while I'm doing the panel. But I think one of the things to be very clear about is there is a lot of people in the encoding and engineering space who are willing to come and solve your problems. The more clearly you can define your problems to that community, then the quicker the solutions will get delivered to you. It's not just about waiting for us to come up with bells and whistles and then you to see if they can fit your problems. I hope you guys agree with that. Can I have a round of applause to the panel, because they've been excellent.